Definitions, models, and equilibrium. We started by describing a model of the so-called exchange economy, an important special case of the model considered by Arrow and Debrew in 1954. The more general one, which we will call the Arrow-Debrew model, includes the production of goods. We will deal with models with the production in section 6.6. Let us consider N economic agents that represent traders of N goods. Let R plus to the N denote the subset of R to the N with all non-negative coordinates. The jth coordinate in R to the N will stand for a good J. Each trader I has a concave utility function Ui, which maps from the domain of R plus to the N to the range of R plus, which represents her preferences for the different bundles of goods. In the initial endowment of goods, Wi equals to Wi1, Wi2, Wi3, until Win in R plus to the N. We make the standard assumption that Ui is non-satiable. That is, for any x in R plus to the N, there is a y in R plus to the N such that Ui of y is greater than Ui of x. We also assume that Ui is monotone. That is, Ui of y is greater than or equals to Ui of x if y is greater than or equals to x. For the initial endowment of trader I, we assume that Wij is greater than 0 for at least 1j. At given prices pi in R plus to the N, trader I will sell her endowment and ask for the bundle of goods xi equals to xi1, xi2, xi3, until xin in R plus to the N, which maximizes Ui of x subject to the budget constraint pi times x is less than or equals to pi times Wi. The budget constraint simply says that the bundles of goods that are available to trader I are the ones that cost no more than her income, pi times Wi. An equilibrium is a vector of prices pi in pi 1, pi 2, pi 3, until pi n in R plus to the N, at which, for each trader I, there is a bundle xi bar equals to xi1 bar, xi2 bar, and so on until xin bar in R plus to the N of goods such that the following two conditions hold. One, for each trader I, the vector xi bar maximizes Ui of x subject to the constraints pi times x is less than or equals to pi times Wi, and x in R plus to the N. 2. For each good j, the summations of xij bar summing for all I is less than or equals to the summations of wij summing for all I. Let R plus to the N be the set of vectors in R to the N whose components are strictly positive. For purpose of exposition, we will generally restrict our attention to price vectors in R plus to the N. When we violate this convention, we will be explicit about it. For any price vector pi, a vector xi of pi, which maximizes Ui of x subject to the budget constraint, pi times x less than or equals to pi times Wi, and x in R plus to the N is called a demand of trader I, and the price is pi. Observe that there is at least one demand vector and that there can be multiple demand vectors. We will usually assume that there is exactly one demand vector at price pi. That is, we have a demand function. This assumption holds if the utility function satisfies a condition known as strict quasi-concavity. Once again, we will be explicit when we will deal with exceptions, since for some common utility functions, such as the linear ones, the demand is not a function but a correspondence or a set value function. The vector zi of pi equals to xi of pi minus wi is called the individual excess demand of trader I. Then x to the k of pi equals to the summations of xi times xik of pi, summing for all I. Demand, the market demand of good k and prices pi, and z to the k of pi equals to x to the k of pi minus the summations of wi k, summing for all I. The market excess demand of good k and price pi. The vectors x of pi equals to x to the 1 of pi, x to the 2 of pi, until x to the n of pi, and z of pi equals to z to the 1 of pi, z to the 2 of pi, until z to the n of pi, are called market demand, or aggregate demand, and market excess demand, respectively. Observe that the economy satisfies positive homogeneity, i.e. for any price vector pi and any line greater than 0, we have z of pi equals to z of lambda pi. The assumptions on the utility functions imply that for any price pi, we have pi times xi of pi equals to pi times wi. Thus, the economy satisfies Moore's law. For any price pi, we have pi times z of pi equals to 0. In terms of the aggregate excess demand function, the equilibrium can be equivalently defined as a vector of prices pi equals to pi 1, pi 2, pi 3 until pi n in r plus to the n such that z to the j of pi is less than or equals to 0 for each j.